Hello everyone, my name is Amiya and I welcome you to this video which is going to talk about 802.11r. The agenda for this video is going to be the introduction for what is 802.11r, what are the different types of .11r technology that are available. We are going to talk about over the air and over the DS in a nutshell. Then we are going to take a look at it on the Cisco side. What are the different modes of Cisco 802.11r deployment that are possible? Then we are going to have a little bit of questions in terms of understanding how we can do things and how do we go about them on the Cisco controller. And then I'm going to show you a quick demo of how do you go ahead and configure all of this on the Cisco Wireless controller. So, what is 802.11r? This is roaming technology that was brought up by the IEEE, and it has kind of really taken off because it kind of saves up on the access point handshakes and the roaming times are less and things like that. What it does is it allows the client and the access points to do the pairwise master key calculation in advance, thereby reducing the number of handshakes that it takes for the client and the access point to go ahead and communicate to each other. You can go through this slide here for more understanding of what is 802.11r. Moving forward, what are the different types of .11r? One is your over the airs and one is over the distribution system. Over the air is basically all about how the communication goes on in the air rather than taking the distribution system, which is spoken about in over the DS kind of technology. Over the air, in a nutshell, like as the name suggests, over the air talks about all the communication between the client and the access points in the air, right? So if we are talking about over the air, as you can see here, if I'm looking at intra-controller, I have an access point AP1 to which the client is already associated. It wants to roam to AP2, let's say AP2. What does it do to roam across to AP2? First thing, the associated client, it sends out a FT authentication request to AP2 and receives an authentication response, all of this in the air. Then it sends out a reassociation request and gets a reassociation response. That's plain and simple over the air. And both of these APs are on the same controller. Now, what do we do if I have my AP spread across different controllers? Let's say AP1 is on controller 1 and AP2 is on controller 2. It follows fairly similar process in the sense that first thing, the client wants to move from AP1 to AP2. It goes ahead and sends out an FT authentication request to AP2 and then it receives an authentication response. Now, once it does that, the WLC1 to which it was previously associated through AP1, it sends the PMK and the mobility message update to WLC2 to notify WLC2 that yeah, this client was on me. And the client then goes ahead and performs the roaming and gets it done. Now that was over the air. Now if we are looking at over the DS, as the name suggests, all of the communications are happening over the distribution system. Now again, same situation, same scenarios. We have got two APs on the same controller and this is intra-controller. Over the DS roaming is what we are talking about. Again, the same scenario, the client is trying to move from AP1 to AP2, let's say. In this case, instead of sending the all the messages over the air, there is a distribution part involved. Now, what happens? The authentication request in terms of an action frame is sent out to AP1. The AP1 responds back to it. Now, in this case, the controller, it sends out the pre-authentication information to the AP2. So here it's not through the air anymore. It is through the distribution system, as in AP to the controller, and since both the APs are on the same controller, so AP2 comes to know that yes, this is all the information for this particular client from the controller itself. After that, the client, it sends out a reassociation request, and the AP sends out a reassociation response. And this way the client goes ahead and completes the roam. In the second step, if we are talking about the same scenario in which my APs are distributed across different controllers, first step, the client, it sends out the authentication request, again as an action frame, to the AP1 and through WLC1. Now, the WLC1, it sends out all the PMK, the pairwise master key, the mobility messages and things like that out to WLC2 to let the WLC2 know that this is the client and these are the client details that have been shared with me, cached with me, stored with me. The WLC then passes it on to AP2, and then the client, it goes ahead and performs the roam off to AP2 because all the cached information is already there, right? Now, from a Cisco point of view, we've got different modes of operation. How do we go ahead and implement FT in Cisco? Cisco Wireless Controller, to be precise. There's something called a pure mode. What happens in a pure mode? In this particular situation, the clients which are not capable of supporting .11r or which are not supporting FT, they cannot connect to the network. This is a pure mode FT deployment. What happens in this particular case? One of the peculiar things that I am going to draw parallels to later on. I want to point out, if you are looking at this authentication key management section, it says that um, the suit count is 1, and then the um, the key management list, it's a PSK, right? Now, sorry, let me correct that. This is for the clients who are non-FT, right? So if I'm looking at the beacons or the probe response for a non-FT network, we will see this. We will see it only supports PSK or 802.1x, and it does not have anything to do with FT anymore. And in the beacon or the probe response, we are not going to see any mobility domain IE, right? So that's kind of a giveaway that this is a non-FT network. So that's your pure mode. There is something else that exists, which is called a mixed mode. What does that do? Now have a look at this authentication and key management section. The suit count 2, right? What does that mean? That means that in the beacon or in the probe response, there are 2 sets of authentication and key management uh, values that are being sent out. One, as you can see, it's a PSK here. And second, it does specifically say that we are using FT and PSK. And notice that the mobility domain is also there, right? So in the mixed mode, if the client is capable of supporting .11r, it identifies and says that, okay, yeah, I see FT is there and the mobility domain I is there, so FT is supported. Let's go ahead and use FT and it will connect using FT. For a client that does not support 802.11r, what does it do? It just says that, okay, yeah, uh, I know nothing about FT, I know nothing about mobility domain, but I do know that if my authentication and key management list says PSK, then I can go ahead and connect to it, right? So both ways, if we are talking about um, a client device that supports .11r and a client device that does not support .11r, in both cases, mixed mode works. However, there is a little caveat. Now, if we are talking about, a client, um, clients can easily get confused with FT, right? So if we are talking about a client which, especially the Mac OS client, they may face some difficulties if you are enabling mixed mode. The reason being that if they have been connected to the network, and all of a sudden this particular change is made, and FT is put in practice, and mixed mode is utilized, then these clients, they get confused. So you might have to just go ahead, delete the WLAN profile from the client, and then try and connect it back again, right? But this is a viable method that was used prior to the next one that we are going to talk about, which is adaptive mode. This is, I would say, probably the most famous and probably the easiest in terms of supporting both the non-802.11r capable and 802.11r capable clients, in supporting both of them. What it does, this is a very tricky situation. Now, what it does is it broadcasts an authentication key management suite count of only one. It does not say that I support FT in the RSNIE, which is the Robust Security Network information element. It just says that, okay, in my list, I'm only doing PSK. There's nothing called FT using PSK, right? But it does have something called a mobility domain IE, right? So when the client is looking at it, it can see that, yeah, RSNIE, no FT. MDIE, there is FT. So how do we take it? So I'll come back to that. I'll come back to that. Now, let's talk about what happens in the beacon or the probe response. When the RSNIE is non-FT, and how does the client really get to know whether the adaptive FT is supported, right? So here in the adaptive mode, we saw that mobility domain IE is there. That is one thing, yeah. That way the client can actually come to know that adaptive FT is supported. There's another thing. Now, if you're looking at the beacon, there's something called or the probe response, there's something called the AeroNet IE data, right? This is the little kind of, Easter egg that tells the client that adaptive FT is supported. Now, there is another question. How does the AP or the WLC come to know if the client supports adaptive FT? It's the same thing like we had earlier with the client device. The WLC or the AP sends out the AeroNet IE, and based on that and the mobility IE, the client comes to know that, yeah, there is adaptive FT that is supported. Similarly, on the AP or the WLC, you see vendor specific data, and based on that, they come to know that the client supports adaptive FT too. So what does an association request from a client that does not support adaptive FT look like? Remember, we spoke about the beacon and the probe response for adaptive FT, right? And we saw that in the authentication key management RSNIE, we had one as a suit count, and the list had only PSK. So when my client does not understand my MDIE or any vendor specific information that I'm throwing out there in my beacons or the probe response, it just looks at the plain old information as suit count 1 and list PSK. So in its association request, it just sends out the same information. It is kind of just ignoring the rest of it, right? How about when the client does support FT? What does the association request look like then? So you can see it just says that, yeah, suit count 1, we are doing PSK, but I understand you have got a mobility domain IE. So it enables the support for 802.11r, having identified it based on the ARRowNet IE extension as well, right? So I hope so far we are good. And if you have any questions, even on any of these subjects that we've just spoken about, just write a comment and I will get back to you. So moving forward, does FT really improve roaming timings? Wow, that's the really big one, because so many times, voice clients, latency sensitive clients, the recommendation is to go to FT. What are the factors by which we see this improvement? So as you can see here, in a non-FT network, a voice grade client perhaps needs about a 150 milliseconds. Depends on the configuration, .1x, PSK, what is the congestion, what is the channel utilization, and things like that. But on an average, let's say, in a generalized controlled environment perhaps, the roaming delay you might find of 150 milliseconds. If we are looking at over the air, this is considerably slow. Again, it depends on some of the other parameters that I just spoke about, but it's still much better. It's 16 milliseconds. Over the DS, not bad. It's somewhere sitting in between the air, over the air, and on FT, and does a reliable job if you have a lot going on in your RF environment and over the air is kind of suffering. So this is a good way to go about it. So these are the statistics that you have, and these are the factors by which you can get an improvement over your non-FT network when you're using FT over the air or over the DS. The good bet. Let's talk about the demo part. So I'm just going to switch on to the controller. Okay. So here I have my SSID, which I've already created, which is called 802.11r. I've created the SSID, which is my FT SSID, and enable it, of course. So in my pure mode, let's say I'm saying I don't want any FT, right? Just disable it. Just disable it. Doesn't matter. I'm going to do WPA2 policy, encryption AES, performer.1x authentication, and that's about it. So at this point of time, my network does not support FT at all, right? Here is the next situation. I go ahead, enable it, right? Over the DS, over the air, we're going to talk about it later, but whatever, just leave something. And then go ahead and do a complete FT.1x. What does that do? That means that only FT capable clients can connect to this network, right? So these are both pure modes, in which one where you have no FT at all, one you cannot have any clients which do not support FT join in, and both are not that good, right? We need to have that resilience and tolerance to allow both of these kind of varieties of clients to come in and join into the network. So we have something called mixed mode. What does that do? It's not very different. We have to enable the FT, go on and enable both modes. Simple as that, right? What does that do? Based on this, it's going to say .1x. Based on this, it's going to say ft.1x. If you just go back in the video and look at the capture that I showed you, it was just saying PSK and ftpsk, right? So that's all that was. So that is my mix mode, and it allows both kinds of clients to connect to the network. Adaptive, here you go. So this is a little bit. Adaptive mode. Again, don't really need FT, because remember in adaptive mode we had only PSK listed out in my RSN IE, right? So I had WPA2 and AES encryption, and I'm talking about only 802.1x or only PSK, right? And that populates my RSN IE with the suit list saying .1x or PSK. However, it is still going to have your MDIE and your ARRowNet IE extension, based on which my client can still go ahead and identify whether the WLAN or the SSID that I'm trying to connect to Does it support adaptive FT or not? Right? So I hope this information was useful, and I thank you for joining in. Have a great day, everyone. Thank you.